In this video, we're going to talk about how to remove a GCF from a polynomial. If you take a look at the first example that we have 3x plus 6, and we need to find something, the greatest common factor of both of the two terms. So what is the biggest thing we can pull out from both of these terms? The first one, 3x. The second one is 6. The biggest thing is 3. Both terms are divisible by 3. So if I pull out a 3 from the first term, what I'm really doing is I'm dividing 3x by 3. And what's left? I just have x. I take 6, and I'm pulling out a 3. I'm dividing by 3, and I get 2. To make sure that this is right, we can just distribute back in. So 3 times x is 3x. 3 times 2 is 6. So we did it right because that matches what we originally had, so we are good. In the next one, we see that we have x's in both. We also have 2's in both. So in this case, the GCF actually consists of a number with a variable together. So we can pull out a 2 from both and an x from both. So what we have left is we have x squared, and we only have 1 left. A lot of people make the mistake of putting a 0 here instead of 1. But 2x goes into 2x one time, so be careful about that. And like I said, we can always distribute back in to make sure we're right. And 2x times x squared, 2x cubed. 2x times 1, 2x, and we're good. The third one, we would factor out. We have x squared in the first term. We have x in the second term. So what's the greatest thing that's shared in terms of x? It's only x. So we can only remove an x. In the first term, we have y cubed. In the second term, we have y squared. So the biggest thing that's in both is y squared. So now we just have to write what's left. We took out 1x. We had 2. There's 1 left. There's y cubed. We took 2 of them out, so we have 1 left. We had 1x. We took 1 out. There's none left. And we had y squared. We took out y squared. We have none of those left. So overall, we actually factored out the entire second term, so we're only left with 1. The last one has 3 terms in it. So we have 3 different variables here. We have x, y, and z. So the first variable is x. We have x squared in the first term. We have x in the second term. We have x in the third term. So the greatest thing in terms of x that we can pull out is just x. Now we look at y. We have y to the third here. We have y squared here. We have y here. So the greatest thing we can pull out is y. Now we look at the z term. We have z squared. The second term we have z. And the third term we have z. So the greatest thing we have in terms of z is just z. So now we have to just write what's left. So we had x squared. We took out 1. We have 1 left. We had y cubed. We took out 1. We have 2 left. We had z squared. We took out 1. We have 1 left. That's the new first term. The second term, we had x. We took out x, so there's none left. We had y squared. We took out y, so we have 1 y left. We had z. We took out z, so we only have 1 left. So we have nothing left in terms of z, just 1. That's the second term. The third term, we factored out x. We had x. We factored out y. We have y. And we factored out z. So this entire third term will be factored out. So we're left with 1. So that is my GCF factoring. So in the next couple of videos, when we do other methods of factoring, it's important to understand the concept of the greatest common factor, GCF, because we can pull out a greatest common factor to make any factoring problem easier.